All right, 1.1, solving simple equations. So starting off, we have some definitions. We have an equation. Equation is a statement that two expressions are equal. So it's something like expression equals an expression, right? The whole thing is an equation, but each piece of it is an expression, right? An expression is just like a string of numbers or a string of variables and numbers. Um, and then the equation is where you have the equal sign and it equals something. A linear equation in one variable is an equation that can be written as ax plus b equals 0. All right. Another way to think about that is that it's an equation, meaning that it has an equal sign in it, and it only has one variable listed. A solution is what you get when you solve. It's the value that makes the equation true, right? So a solution might be like x equals 3, right? That might be a solution. Equivalent equations are two equations that have the same solutions. And we can think about that a little bit. At some point while we solve them, they'd be the same exact thing. So as an example, we could have like x plus 1 equals 0, or 2x plus 2 equals 0, right? We can kind of see the similarities here. This is x plus 1. This is 2x plus 2. We multiplied by 2 there. Those two would be listed as equivalent equations, right? Because they would have both the same solution. And the solution there would be -1. All right, now we go into solving, right? These are all equations because they have an equal sign in them. They are a linear equation of one variable or in one variable. Linear meaning nothing is squared, right? You know, we all know what like x squared, right? That's not a linear equation. We just have a plain old x here. And it has one variable, meaning that only the x is listed. There's not like an x and an m or an x and a y, right? Just the x. So solving this, we have x plus 3 is -7. So we're going to subtract 3 from both sides, and we'll have x equals -10. All right, number 2. M over 5 is -4, or equals -4. Well, it's m divided by 5, so to undo that division, we need to multiply by 5, right? We multiply by 5 on the left side and the right side. So our 5's will cancel, and I'm left with m equals, what is -4 times 5? That'll be -20. Moving on, number 3. We have 6x equals 15. It's 6 times x. To undo that multiplication, we need to divide. So I'm going to divide both sides by 6, and we're going to have x equals 15 over 6. Now, it can be tempting to type that in your calculator. And I'm okay with us using our calculators. I think calculators are good tools. But if we start off without a decimal, I want us to end without a decimal. So if you have a calculator or if you learn how to reduce this fraction in your calculator, that's okay. But we want to leave it as a fraction, okay? We can reduce this. The top and bottom is both, we could multiply 3. So we can divide by 3 and we'll have 5 over 2. So our answer, the answer that I'm going to circle, is x equals 5 over 2. Okay. Now, one other thing here. Well, let me recap. We started off with something that did not have a decimal. There's no decimal in the problem, so there's no decimal in the answer, right? Generally, I like things listed as fractions. Also, I like improper fractions. I do not like mixed numbers, right? We know that 5/2 could be listed as 2.5, right? In the math world and from now on, unless we're dealing with measurements, sometimes measurements we like proper fractions or mixed numbers like this, but generally I'm never going to use that, okay? Leave things as improper fractions, all right? Leave it as 5/2 or 5 over 2. Number 4. This one's listed a little bit differently. We have the division sign. Normally, we don't have the division sign anymore. It'll just be written as like a slash for like a fraction bar. So that's what I'm going to do. I'm going to rewrite this as if it was a fraction. So this will be x over 2 equals 4. Now this looks a whole lot like number 2, where we multiplied by our denominator. So I'm going to multiply both sides by 2, and I will have x equals 8. All right. Next up, we have some word problems. An amusement park offers a ticket for $12.95 off the original price P. Write and solve an equation to find the original price. The discounted price is $44. So what this is telling us is that you have a coupon, or it's something like you have a coupon for $12.95 off as a ticket, right? And you give your cashier, or the person that's taking tickets, or whatever it is at the amusement park, that coupon for $12.95 off. And then they tell you, all right, your total is now going to be $44. Okay? It's good to understand what is happening in the problem. So whenever it goes to write and solve an equation, there's lots of different ways we could do this. There's different ways that we could write the equation. The way that I saw it as, we start off with x, that's the cost of the original ticket price. Then we take off $12.95, and we end up with 44. Okay, so again, we started off with the regular ticket price, X. That's what we're going to try to find. And then we took off our discount, and then we ended up having 44, which is what we paid. This is part of the answer, right? In these problems where it says write and solve an equation, I want to see this. I want to see that step, right? I don't want to just see the answer. All right, now that we have this written, we can solve this. And the way that I'm going to do that is I'm going to add $12.95 to both sides. And I will end up having x equals $56.95. And because it's money, I'm going to put a dollar sign there. And there we are. Okay. Moving on to number 6. The length of a flag is 1.9 times its width. What is the width of the flag? So let's think about this. We've got a flag. The length of the flag is 1.9 times the width. So maybe the width would be x, and this could be 1.9x. The length is 9.5, so that would also be there, right? We all know that flags, well, those are normally rectangular. Sometimes they're square, but this time it's a rectangle. So 1.9x and 9.5 are going to be equal. Whenever I divide, I end up getting 5. So x equals 5. Now x, it happens to be that we set it up in a way that the width, x, is what we had to solve for there. So that's what we got. And we got, what is this, 5 feet, or 5 feet. There we are. Well, let me talk about this again. On our homework, on your homework, whenever you're doing the homework, I don't want you to just have the answer. I don't want to just see a bunch of answers. I want to see some work, right? I understand that maybe if you were doing this problem on your own, you wouldn't draw the picture. I get that. I'm okay with that. But you need to have some work, okay? Number 7, you spend $8.64 on 12 cans of food. Each can costs the same amount and is on sale for 80% off the original price. The following week, the cans are no longer on sale. You have $10. Can you buy 12 more cans? So we all get the scenario here. You go to the store, you go to Walmart, you buy 12 cans of, I don't know, green beans or something. And the green beans are 80% off. Or on sale for 80% the original price, so they're 20% off. And you're able to buy them for $8.64. The next week you go back and it turns out they're not on sale. And while you're standing there in the grocery aisle, you want to know, how many can I buy? Am I able to buy 12 or can I only buy 10? You know, how many am I able to buy? So originally, or starting off, we need to figure out what is a regular priced can of green beans or can of food here. Or what is this? Can of cat food. All right, so starting off, we're going to have 12x, 12 cans, and x will be the cost of a can. So x equals cost of can, right? The regular cost, okay? Now, so 12x would be the regular cost of a can, but here we've got it on 80% off, so that's 0.8. And that ends up being $8.64. Okay. This here, this 0.8, I like to use 0.8, but you could also use 80 over 100, showing that it's 80% of the original cost, of the original 100% cost. Either way is good with me. Now here, I'm going to multiply 0.8 times 12. 0.8 times 12, oops, that's a 13, is 9.6. So 9.6x equals 8.64. Now to solve, I'll divide by 9.6. So 8.64 divided by 9.6 equals 0.9. So x equals 0.9. So that is the cost of one can of cat food, right? So that's 90 cents, right? Now we want to know, with $10, can we buy 12 cans? So I'm going to say, well, 12 times x is going to be 12 times 0.9, which is 10.8. So $10.80. So now we look at that and we're like, well, that is a larger amount than $10, so no, we cannot, oops. So no, we cannot buy 12 cans. So no, we would need $10.80. All right. Some of your book problems are going to be kind of like this, where it's not asking for like an x equals answer. It's asking for a longer process, more thinking in it. All right, number 8. The letter B represents a non-zero constant. Okay, so x is not 0. Solve the equation for x, then find a value for b so that the solution is positive. All right, so this one's kind of weird. We start off with, and I'm going to rewrite this, we got bx equals -7. So it says solve the equation for x. So that's what we need to start off with. And what we're going to do here is we're going to pretend like b, that's our other variable, is just a number. We could pretend like it's 5 or an 8. If it was a 5 or an 8 or some number, we would divide by b on both sides. They'd cancel on the left, and I'd end up having x equals -7 over b. So that's the starting off of it. Here, I can circle this. That's part of our answer. We have now done this part of it. Now we're supposed to find a value for b so that the solution is positive. Right? So we look here, and the solution would be whatever this turns out to be. So we need to think about, negative is to 7 divided by a number. How would we make that positive? Well, what if it was like a 5? Let's just plug that in just to see. What is -7 over 5? And I'm going to actually give this as a decimal. We got -7 divided by 5. That gives me -1.4. Well, that doesn't work because we need it to be a positive number. What about -7 over -5? Well, -7 divided by -5 is going to be positive 1.4. So that one works. So we'll say b equals -5, right? And that is the other piece of it. Here, I'll make that a different color so we can see what we're doing. That there is finding the value for b so that the solution is positive. Okay? We will have some problems like this on the homework. Make sure that if you're confused, if you have a hard time with the homework, shoot me an email and I'd be happy to help. So there's this. Make sure that you have these definitions somewhere or that you know these definitions. Remember, an equation has an equal sign, right? An expression does not. Expression, no equal sign. Equation, equal sign. All right, that is that.